morning, everyone. Welcome to the OnGo Insider session, the state of CBRS. I'll do a quick intro of the speakers, and my name is Oren Binder. I lead marketing for the OnGo Alliance. We have with us today Masoud Olfat, VP Technology and Ecosystem at Federated Wireless, and also president of the OnGo Alliance. Joe Lindholm was the CEO and co-founder of Infinity and a board member of the Alliance, and Richard Bernhardt, who's VP Spectrum Industry at WISPA. From those of you who are less familiar with GoToMeeting, we'll take questions during the webinar. You have a questions and chat interface on that in front of your screen there. And let's get into it. We'll start with Masoud.
Okay, thank you very much. Good morning, everybody. Thank you very much for joining the OnGo Alliance webinar. Yes, so OnGo Alliance and CBRS in general has kind of created a solution that brings both government and commercial ecosystem together for generating a technology that provides maximized economic and national security benefits. OnGo Alliance, along with WIN Forum, Wireless Innovation Forum, in the past almost 11 years, we have been working with different part of government, including the Department of Defense, currently Department of War, with the FCC, which from a policy perspective, with NTIA that addresses the spectrum policy for government spectrum, and the Department of Commerce helping us developing the certification plan and propagation models. All of them have been working very closely with the industry elements, going from WISPs, fixed wireless access, a representative from mobile industry like Verizon and other MNOs, a representative from cable industry such as Charter, Comcast, Cox, and enterprise. A lot of representative from private wireless industry. All of them have been working together to come up with an efficient solution for providing an efficient spectrum management. If you go to next page, please. The discussion started around 2012 when the PCAS project was introduced by the White House, and through 3 years of study, the policymakers and Department of Defense were looking at the possibility of sharing a spectrum, the mid-band spectrum between industry and government, and they ended up with the rule and order in 2015. The first rule and order came out that allowed the development of CBRS in 3.5 gigahertz band. And in 2016, OnGo Alliance was generated to make sure that we bring the spectrum management that is addressed in the NPRM, in the rule and order, and also the advance in the technologies such as 3GPP. And to that end, we brought up different sectors of the ecosystem, going from DoD and industry together. The technology was generated through a lot of interaction and discussion in OnGo Alliance and WIN Forum by end of 2019, and we started the actual deployment early 2020, along with the PAL auction number 105, which brought close to $5 billion and created about 22,000 PAL licenses, the priority access licenses in the country. In addition to that, we created band 48 and N48 in 3GPP, addressing the CBRS band. and we also generated a huge ecosystem going from a lot of mobile devices, including mobile phones coming from major mobile phone providers such as Apple and Samsung, and also major RAN providers, Ericsson, Nokia, Samsung, and other JMA, and a lot of other RAN providers. The technology has been evolving and the deployments have been evolving starting from 2020. The ecosystem is pretty young. Within 6 years, we have grown from zero with a new technology to more than 437,000. Actually, 435 was a number from a week ago, and we have been growing. So more than 437,000 radio access, mostly base stations, E node B, G node Bs, um, have been deployed in this band. And also we have hundreds of use cases, a lot of subscribers that we are going to discuss. In addition to that, one of the major advantage of this band is because by introducing a concept called SAS, Spectrum Access System, is to allow scalability and flexibility to improve the ecosystem. Basically, by introducing CBRS 2.0 in 2024, we suddenly opened the by doing some software change, we suddenly opened the band for additional 72 million Americans, and we continue growing and making the ecosystem more efficient. Next page, please. Well, as I mentioned, the major advantage of OnGo CBRS is by bringing diverse ecosystem members. So this is not a technology that only addresses the need for big mobile operators or cable operators or only the private wireless. This technology is a solution that provides efficient deployment for all sectors of wireless ecosystem, going from big operators, MNOs. Currently, we have a major part of the deployment done by consider a big MNO, Verizon, and then several MSOs are also ramping up their deployment. Cable industry, Charter, Comcast. In addition to that, the system integrators are using CBRS to deploy and increase the use of wireless in the private sector and enterprise. The introduction of neutral host networks, the introduction of passive DAS and active DAS are very efficient by using CBRS band. Another factor of the ecosystem are equipment manufacturers, whether they are device manufacturers or radio access network. The major ones have all developed the band 48 and 48 in 3GPP, and also we have major providers of fixed wireless access using their proprietary technology for CBRS, companies like Cambium and Terrano and a lot of others. If I might not be able to mention every one of them here. In addition to that, the SAS administrators, they have gone through certification, they have created the SAS and also the sensor network. All of these have brought the CBRS into life. Currently, OnGo Alliance is focusing to make sure we grow the segment of end user members. Major companies like Chevron, John Deere, General Electric, airport industry are coming into the picture, education and healthcare, like libraries, campuses, they are all using CBRS. We have thousands and different a lot of different users and a lot of different use cases that can be addressed by CBRS. The focus of the alliance is on all aspects of the ecosystem, going from the technology development. OnGo Alliance started with 3GPP, but very quickly expanded to proprietary technologies as well by generating the SaaS requirement as well as the coexistence and network services, especially for private wireless network and neutral host. Um, Doing a lot of advocacy work to make sure that the government industry are involved, and we establish a growing and strong ecosystem by engaging and creating the regulatory relationship. Um, the certification process, it has been a very efficient certification process, both for the radios, for the devices, as well as for SaaS administrators and sensor network. All of these have been generated in a fairly short amount of time and have been growing very fast. Next page. Um, so I'm going to show a little more detailed statistic, but just in a snapshot. CBRS currently has brought more than 1,000 CBRS operators and deployment networks in the country. We have the amount of investment going from spectrum investment, radio, radio development, equipment manufacturing, standardization work, technology development, SaaS development, sensor network development. Um, it is a little more than $14 billion. So as you see, there has been a huge deployment in the CBRS ecosystem. The number of end user devices that have been certified supporting band 48 on CBRS is about 1,100. We have more than 1,800 private network deployed in the CBRS. We have more than 437,000 so-called CBSDs, which is a replacement for access point or base station or E node B or G node B, deployed in the country, including fixed wireless clients. And more than 98% of the states, and I'm going to show some maps, have been deploying CBRS. So as I mentioned, CBRS brought both industry and policymakers together to generate this. I think this showed a very good example of how industry and government can work together to generate an efficient sharing mechanism in mid-band. And this model can be easily expanded to other spectrum. We are not going to stop at CBRS band at 3.5 gigahertz. This is a model that have been expanded. One example of that we saw in 6 gigahertz that now we are talking about AFC already deployed, and a lot of other countries are also following that. AFC is using some of the kind of incumbent protection methodologies that have been already done in CBRS. Very interestingly, CBRS has introduced a portfolio of different mechanisms for sharing between primary and secondary users, and also among the users in the same level of authority. This is very interesting, and this is very important for the future health of the spectrum management in the country. In addition to that, CBRS has filled the gap between the unlicensed and licensed deployment. Um, as we know, traditionally, if you go to the next page, please, traditionally the industry has been looking at two models. One model was the unlicensed, which mainly supported by Wi-Fi, and the exclusive license, mainly supported by MNOs. Um, each one of these models, they have their advantage and disadvantage. A shared CBRS shared model, which is creating some license by rule, is generating a very efficient model that is managed by software. This is a very important thing. We don't have to go and get permission and you go through a very heavy and, by the way, costly process for getting permission for exclusive license, as well as be prone to a lot of congestion. The CBRS shared spectrum, it provides a license by rule. Um, uh, Basically, it's not unlicensed, it's not fully exclusive. It provides a license by rule access to the spectrum using a central system called SAS. I think I want to emphasize on that. SAS is a software, it's very scalable, and it can maximize the efficiency of spectrum usage. And basically, the end users, they don't have to deal with the SAS. Only the operators are going to deal with the SAS to get permission. And getting the license access going from a long time, such as a year or more, to less than 1 hour. It's a matter of actually minutes for you to get access to licensed spectrum. And also, it introduces a lot of scalability to introduce kind of a clean, interference-free spectrum, because SAS could manage the coexistence among the users as well. Next page, please. So the architecture of the CBRS, just to show that in a very, very short amount of time, we have a central system like a SAS that on one side can deal with the FCC databases and government portal, and also relying on an efficient nationwide sensor network to identify and detect. And I use the two words deliberately, identify and detect, because sensor networks detect, and then through databases and portal, we can identify the primary user incumbent activity. And by doing that, we can, using a protocol that runs in a matter of seconds with the operators, and with that, we can efficiently decide which spectrum in which power the operator can use, and basically make the spectrum assignment or a spectrum authorization, in a better word, very efficient, done in a matter of minutes. The operators can use domain proxy. In other words, even the radios, they don't have to be worried about communicating with the SAS. We have introduced the concept of domain proxy, that the network management system can directly talk to the SAS. In other words, the radios really, even the radio itself, do not have to be even worried about SAS. The network management system can do that. For detection of incumbent activity, we can use either sensing, or we can use informing incumbents through portals. And also, SAS is dealing with the FCC databases, such as the Equipment Authorization System, EAS, and the ULS every 24 hours. Next page, please. Okay, let me talk a little bit on the statistics. Before talking about the statistics, as I said, CBRS can be used in many different use cases. This is not limited to urban area or rural area. CBRS can be used to enhance the coverage in many different areas, including rural areas, for used by MNOs. It can be a coverage expansion by MNOs. Currently is being used, and also the rural operators by WISP and fixed wireless access, as well as it can be used for densification and capacity enhancement in urban areas. Especially by introducing the dual band radios, recently FCC allowed a waiver for two companies to deploy dual band C-band and CBRS. They can easily be used for expanding the capacity of kind of operators and entities that are using those dual bands. On the right side, I'm showing statistics on the amount of spectrum that is being used per county. As you see, majority of the counties in the United States are using a heavy amount of CBRS spectrum, whether it is PAL, Priority Access License, or GAA, the Generalized Authorized Access. Keep in mind, Generalized Authorized Access, it's a license by rule. They can get the authorization from SAS, and they can deploy, and SAS can manage the coexistence among those users as well. So as you see, in the majority of the counties inside the United States, the amount of spectrum is being used is significant. As you see, for example, the counties in Southern California, in Texas, they have been using actually more than um, uh, many gigabyte of spectrum. Like for example, 200 gigabyte of CBRS deployment has been used, gigahertz, I'm sorry, of spectrum have been used in counties like, for example, if you go to the Southern California or Texas, you see the kind of the dark red. This shows a lot of spectrum have been used in CBRS in these counties. Next page, please. In this page, I'm on the left side, I'm showing the number of CBSDs per county. This is very interesting. You see that majority of the counties are we have used a lot of CBSDs. So CBSDs are deployed using CBRS, both PAL and GAA. I'm sorry, I this should be I should have changed it. This is not March. This is as of actually 3 days ago, as of April 2026. So you see that counties in Texas, in California, and in a lot of other counties. And by the way, this is a logarithmic scale. So, for example, a county like this one in Southern California, which is close to the 10 to the power of 4, which means about 10,000 different CBSDs have been deployed in this county. By CBSD, we are talking about RANs, radio access network, access point, or eNode Bs or GNode Bs or base stations. On the right, by the way, there are some portals that you can see the actual number per county. And very interestingly, as basically through some studies, it shows the basically the compound annual growth rate of CBRS has been about 43.2% going from 2024 to 21 to 24, and it is growing based on new studies. One additional item before I pass it to my friends is that we have done some simple calculation by counting the number of subscribers that are addressed. So on the left, I'm showing the number of access point eNode B, GNode Bs using the whether they are eNode B, GNode B, or fixed client, high power fixed client. And on the right side, using those numbers, I'm calculating the number of subscribers that are using CBRS. Basically, I'm not assuming that the fixed clients are kind of giving service to subscribers. I'm only considering the percentage that are using eNode B, GNode Bs, and we have come to the conclusion that based on 2025 study, and this could be expanded for 2026, close to 14.5 to 15 million subscribers, and actually this has grown because this study are from last year. Close to 15 million subscribers are being supported by CBRS, and this actually puts CBRS as the fourth largest and actually the fastest growing wireless ecosystem. So what CBRS is not necessarily competing with MNOs, with like AT&T, Verizon, T-Mobiles of the world. We are not competing. Those are also using CBRS. However, it's from a wireless ecosystem perspective, it puts us in the fourth largest one, and this shows the importance of CBRS for the national interest. So with that, I want to stop and pass it to Mr. Richard Bernhardt from WISPA to talk about fixed wireless access. Thank you.
Hey, thanks, Masoud. Appreciate the information and background on CBRS. As many of you know, CBRS has been growing steadily. I don't think we can call it an experimental band anymore. It is now a well-established band with many different segments and many different uses. I'm going to talk to you a little bit today about fixed wireless access as well as the wireless internet service provider use within the band. Then we're going to progress on to some of the types of uses that are going on and the future, where CBRS is going. So let's start off early here and talk a little bit about what wireless ISPs or WISPs do in the community. There is a very heavy focus with WISPs on suburban and rural and ultra-rural communities. This is very important to solving for issues of the digital divide. They provide options, sometimes the only option, in areas that are hard to reach and in areas that are highly residential and rural. So one of the key purposes that CBRS serves is the ability to provide service platform that well serves rural and suburban communities. Um, Presently, and this is why I'm saying it's no longer an experimental band, CBRS through WISPs and FWA providers are serving over 10 million residential customers in the United States alone. And that's a very substantial number of customers, especially since most of those are in areas where they have less than two choices for internet options. And in many cases, they are the only choice for internet option. Um, as you can see by the next statistic, that means that they serve over 75% of those areas that are primarily in rural areas. And um, of those, WISPs utilize greater than 70% CBRS for serving this purpose. So while WISPs do use a wide variety of options of spectrum that run from unlicensed all the way up to the licensed bands, right in the middle with CBRS, where you have licensed by rule and priority access licensees, they've been very prominent. And it's very important to say, as Masoud noted, that Auction 105 took on a different characteristic than typical auctions do. The $5 billion that was spent on Auction 105 included a great number of smaller entities because the size of the licensed area for priority access licensees were county size. And as a result of it being that, instead of very large areas like PEAs and others, they were able to work, especially in the rural areas, with licenses that don't typically come up in normal licensing parameters. So this allows selective areas to be chosen, smaller areas to be served, and they could serve rural and suburban areas without interfering with urban areas, which very typically are taken by licensees like MNOs. Um, but they don't only serve residential solutions. WISPs and FWA providers, this is providers that utilize point-to-point, point-to-multipoint solutions, service over 3 million enterprises across the United States as well, which means that they're into all different kinds of service needs. And within those enterprises and extending out to other uses, there are over 50 different vertical markets which are critical to the United States commerce and to operations throughout the US. And those vertical markets include things like precision agriculture, dairy, aviation, schools, K through 12 and higher education, venues, accommodations, transportation, and many, many more. The list is pretty much in everything that we do in everyday life as well as industrial uses. As Masoud noted, CBRS has been growing since day one, and what they're serving has also been growing since day one, and so is the FWA and ISP market by providing now into an expanding number of private networks. These are networks serving specific interests of both commercial and governmental needs. This includes things like schools and businesses and corporations and an industry and manufacturing and many other areas where private networking is really critical. Let's move on to the next page, please. So there are a lot of reasons why CBRS is a critical band for the areas that I've spoken about for wireless ISPs, as well as for generalized fixed wireless providers across the US. And I want to note straight up that one of the things that CBRS does that virtually no other band does well is that almost everyone lives in CBRS. That includes mobile providers, fixed providers, and hybrid providers. We have providers that are as small as a couple of users all the way up to thousands and thousands of users across the United States. And they carry over the kinds of uses that you couldn't do in a widespread nationwide singular exclusive license. The choices are not really available for clean available spectrum that would be available in any other band. So the first point is that it's significantly easier, faster, and cheaper to deploy than other choices in rural terrains. And this includes purely fiber, though a lot of operations with CBRS utilize fiber in their deployment. A hybrid network of fiber and fixed are very, very common these days, and it allows the best tool to be used that's needed for the best solutions. New solutions deliver fiber-like performance in CBRS at a fraction of the cost. So while you don't have to dig trenches and you don't have to put things up on poles, a lot of the delivery of CBRS can be done in the same fashion as any other fixed wireless deployment. And because it's low mid-band solution, there's a lot of flexibility in the deployments for that with rapid speeds and equivalent performance to a lot of other solutions, including fiber. Um, Last year, you can take an example that we had an awful lot of disasters in the United States, and I anticipate, unfortunately, we're going to see more of them coming our way with changes in weather patterns, increased population, all of the many things which cause reasons for radio networks and even wired networks to go down. But one of the great things about fixed wireless is it can be restored rather rapidly, and even after major forest fires, flooding, droughts, and many other issues, they have been able to be restored. And there have been instances of restorations, for example, in Puerto Rico and others, in other areas of the United States, where terrible disasters have happened, and the services have been restored in very short order. The next point is that the operators of CBRS have been able to offer clean spectrum. What does that mean? It means that the noise floor is very low. And because we have spectrum access systems directing traffic and handling the grant system for the use of the bands, we have very, very little amounts of interference. I'm not going to say there's no interference. There's no such thing as a band that doesn't have any interference. But for the most part, it acts like a licensed spectrum in the sense that it operates under the control of the SAS and therefore is deployable much like you would in a fully exclusive licensed band. And one of the great things about CBRS, and we found it to be true, is it can be deployed virtually anywhere. It may require additional radios to do it. We may use a small cell format, which allows for localization, and that is terrific because it allows specific areas to be addressed. Let's move on to the next slide, please. So where is CBRS going? I think it has a very positive future, but I want to touch on a few things that can make CBRS take off even more than it has taken off so far. Last year, with the implementation of CBRS 2.0, the ability for as many as 72 million additional Americans was put forth by a cooperation between the armed services and the industry to reduce some of the areas where there was a little bit of over coverage and protection of incumbents. Very thankfully, the incumbents worked with the community in order to reduce some of those barriers, allowing the CBRS to expand extensively in areas that had been reserved for either the Navy radar systems or other systems in the past, to a more very focused look on those things. And the FCC declared that as many as 72 million Americans, additional Americans, would have access to CBRS. That cooperation was done in a very short period of time between the Navy and the government and industry operators. We can foresee moving into this year and next year additional examination of areas in CBRS to make improvements, such as what to do with devices that are above 6 meters in height, protections of fixed satellite systems, and others where if we refine based upon the data taken in by SASs and the community, we refine the regulations and the rules and the approach such that even more operators will be able to operate with sound network principles all the time. So watch for that. We don't necessarily call it 3.0, but it's a good way to reference things on growth. We are adding additional features and functions, making it even more flexible than it has been in the past. And this has traditionally been something that CBRS has been able to do rapidly. If you look at some of the features such as grouping and looking at antenna types and different types of things that come through CBRS, you can see that features and functions can be added and the SASs can adapt to them and operators can adapt, as well as manufacturers of the equipment. This includes more security and surveillance and camera use. It includes the use of DAS, both active and passive DAS. This includes additional grouping characteristics and many other things to come. One of the key things that we have to do over the next year to make growth happen in CBRS, and it will make growth happen in CBRS, is to overcome regulatory uncertainty. There is no question that having CBRS in the marketplace as a solid solution um, has produced amazing results. So it would behoove regulators and lawmakers to clearly call out that CBRS is achieving those goals and that their goals are different from other bands, and make that a clear statement, because if we can overcome regulatory uncertainty, that will make the band even stronger. And I can see an awful lot of deployments in things like the BEAD deployments, the infrastructure deployments that are coming over the next 5 years. The implementation of private networks is exploding, and with regulatory uncertainty removed, you can imagine that going up multiple times over where it is today and spreading to other bands where it makes sense. So it is really critical that we solidify the uncertainty, but at the same time, this is a format that is replicable, and with spectrum sharing has a tremendous opportunity to move forward. There is more and more penetrative growth in vertical markets. And with these private networks, as we've talked about, a real good example of this is airports. If you go to one of your major airports today, like Dallas, Fort Worth, and Miami, and other airports throughout the United States, these are very busy airports. You are going to see functions and features operating both in the forefront that as you're walking around the airport, you can see, and those that are in the background, which you don't see, such as management of the luggage, where vehicles are going on the tarmac, managing of assets, and so forth. Those things are being very, very heavily taken up by CBRS, and we're seeing the same thing in industrial uses. You can take a look at manufacturing facilities and see where quality control is going. There is also a growing and huge opportunity for much more indoor growth in CBRS. It's a wide open opportunity. There's quite a bit of use right now, but it is certainly a wide open area for growth, and a large expansion in small cell deployments and development. So we have seen that in the fixed wireless environment, CBRS is playing a major role and will play an even more major role. We have seen that there are new features and functions coming to CBRS, and that we do need to overcome regulatory uncertainty. But with blockades taken out of the way in terms of that, the growth is almost unimpeded. So I would now like to turn this over to Joel Lindholm.
Hi, I'm Joel Lindholm, on the board of directors of the CBRS Alliance, and I am also the co-founder and CEO of Infinity. Here to talk to you a little bit about how enterprises are using the CBRS spectrum for their purposes. I would like to separate this into two different areas. The first part I'll talk about is something called a private network. And this is a case where the enterprise is able to use the spectrum for their own purposes, and they can put whatever applications they want on it. There's certain things about the spectrum that we're using for cellular purposes that have advantages over things like Wi-Fi and over things that they would normally not be able to get with an exclusively licensed spectrum. And so customers are using this for a variety of applications, and one clear reason for using the network is for quality. It's a very steady throughput, capabilities, latency that are all determined by the private network, and it's able to be put inside the company's firewall using the radios, the packet core, the devices that are pertinent to that particular enterprise and can be customized for their usage. And they can guarantee a quality service to things like the point of sale terminals or push to talk phones or video surveillance, which needs some network that's not going to allow interference but give a high quality signal to it. Another set of use cases all revolve around mobility, and where other types of wireless networks might have inconsistencies in its ability to have mobility. But with the case of CBRS private networks, you're able to do that. So manufacturers or warehouses are able to put their forklifts or their automated guided vehicles on this type of a network. And you'll see a whole emerging set of capabilities around physical AI and robots that need some sort of intelligence in order to communicate with not only with its instructions, but also getting new instructions from whoever is driving that robot and telling it what it needs to go and what it needs to do. So you have a combination of the mobility aspects as well as the additional intelligence of these applications. There are also these other areas of the country that are using it for critical infrastructure purposes. So many utilities are using it for just things that are needed to be done to give us power and gas and whatnot within our own communities. Airports using it substantially in order to provide communications and visibility and baggage handling services and other things that are critical to the airport, as well as places like shipyards and seaports and rail yards that are just critical infrastructure that are relying on us to get not only our power, but to and from places and getting our goods to and from us. Many of these use cases are probably not seen by the average person. So people that are used to going to the store, to the office, or to the hospital may never see the fact that there's a private network that is critical for them to be providing the service or using the service that they're needing to. And these are typically delivered by many system integrators that can come in with a kit related to communications or to security or to warehousing applications or specialized 5 nines type networks that are needed to run airports and shipping yards. And so the flexibility that is provided by CBRS is enabling these types of applications without a lot of the headaches that would have been previously required for getting cellular spectrum and cellular networks. The other major use case that I'd like to talk about is using the CBRS spectrum for mobile coverage. In other words, we call it neutral host. And in this case, we're talking about a building or an enterprise getting mobile coverage from AT&T, Verizon, T-Mobile, their MVNO partners that might be needing coverage in a building. Previously, there's significant business obstacles towards solving these problems, in which case only the biggest buildings could justify getting coverage inside the building. And that was because it required the mobile operators to bring their exclusively licensed spectrum to the building. And a lot of that requires complicated legal agreements and licensing and integration and interference with the macro network that is in that area. And so there are some fundamental obstacles that only allowed it to be in the biggest of buildings. Within CBRS usage, we offer that flexibility. We're able to do it in a fraction of the time and without a whole lot of additional effort from the mobile operators to do that integration. What that does is it gives the enterprise the ability to now put this network in any building of any size. And In a lot of cases, what that's doing is it's eliminating the dropped calls. That's giving you a high quality cellular network inside the building. No more dead spots. And so when you're walking through the building and you're not getting a good call quality or communication or dropping calls, like all that stuff goes away. The other aspect of the network is because it's integrated with the mobile operators, is it comes with all these other services, including the ability to call 911. So we're directly integrated into the public service answering point, the PSAP, if you will, so that when somebody makes a 911 call, they're able to call the first responder, and that first responder knows at a very granular level where to go within the building to provide its services. The other aspect of that is when an alert is pushed out to the mobile phone, any of these wireless emergency alerts, and those could be presidential alerts, a hurricane, a fire, or any Amber alerts, those kind of things are pushed out to the mobile phone from the network, and those are only coming across the cellular network. I know a lot of people talk about, are there other alternatives to doing this? But these are the things that are tightly integrated and provide safety services for the enterprise. It's a crazy thing, but within the United States, the government mandates that before you get a certificate of occupancy, there's a public safety DAS system that needs to be put in place. So the first responders, when they show up, can communicate with one another. But the thing that we forget about and we don't mandate is the fact that there needs to be a neutral host system in the building so they can call the first responders in the first place to come in. And in many other countries around the world, they mandate that kind of communication capability, not only for the people, but then also for those first responders. If you look across the buildings in the United States, roughly 80% of those buildings lack adequate mobile coverage. Also, from that enterprise perspective, they want all three mobile operators or those MVNOs because they don't know who's going to show up in the building in the first place. Now, what we've said here is the enterprise has a set of needs, and they're willing to pay for this kind of a service. And we've lowered the barrier to entry for the mobile operators to a near zero level so that it is a minimal amount of burden for them to join these networks at the same time. And when I go through this, each of these industry verticals have a different need. A school might have the need because mom and dad want to call their kids, or if there's an emergency, they need to get a hold of one another. Hospitals need fundamentally for the doctors and nurses to give high quality communications. I can't tell you how many times I've heard where the surgeon is in the operating room and is unable to communicate, and they need to. And you would think that places like warehouses and manufacturing are probably not a big need for this kind of neutral host service, but in fact, while they do want to have the ability to communicate, they have a big need for safety. Just simply calling 911 if there's ever an accident within the building. So when you go across these industry verticals, they have both the need for what I was talking earlier about the private networks, but also for the neutral host networks. And they're two fundamentally different things. One is integrated with the mobile operator, meaning the mobile operator coverage, and the other is a private network, which is intended to be private to that enterprise. When you look across the United States, I mentioned a few of the verticals earlier, but there are many, many different verticals that are needing this. Everything from airports, which are critical for communications, for operational purposes and baggage handling and other aspects of just the fundamental running of an airport, to the education market, whether it be higher ed or whether it be elementary schools. Tribal nations is another good example where a lot of these are in rural areas that don't have the type of coverage. And this is an economical way for people to go and adopt said coverage. Hospitality, oil and gas, think about like these rural areas like where mines are and oil and gas refineries that have both the private network need for their operational purposes, but also the neutral host for the safety purposes. As an example, I'll talk about just the city of Las Vegas. In one area, you have a number of different requirements, from the large venues that would host a Super Bowl or some other NCAA type sporting event that have communication needs for neutral host, that also has private network applications so the referees can communicate, and they do that very well today over this type of a network. There's other hotels that could be resorts, or they could be boutique hotels, or they could be just your classic Marriott that might be out there that has the need as well, both for, again, private network needs, where the people helping clean the facility or the security guards, and then all the guests that come in and out and need it for communication or safety purposes. There's rural areas of these towns that need a fixed wireless access or WISPs to cover these far removed areas and provide connectivity. Take your city buildings, take the schools, take the metro areas. So there's a variety of use cases all sitting within an individual city, not to mention the hospitals that would be also in this same area. Not to talk about all the different individual logos that you see here, but these are kind of the who's who within each of these different enterprise verticals. Various different schools, hospitals, airports, these industrial companies, whether they be utilities or factories or other people that need this Industry 4.0 type capabilities. The utilities that are using it for just monitoring their systems and communication in areas that are not typically covered in other mechanisms. And then last but not least is the public sector, and most of these Army bases or Navy bases, take your pick, are in rural areas that don't have communication. And if there's ever a need for somebody to have visibility into their environment, it would probably be the military folks, let alone the broad set of uses within the public sector. And so, yeah, who's who. Fortune 500 are using these types of networks in a variety of different ways. They've seen the benefits to it, and I think we're just literally at the tip of the iceberg of adoption, because the flexibility is there, the quality of the network is there, the ability to provide a licensed approach using the SAS for the availability of cellular spectrum, and the number of devices and use cases that are popping up. So the innovation band so far has been off to a great start, and we can just see the upside for the future. Thank you very much, and I'll pass that off to Oren.
We do at the OnGo Alliance have collateral that we're working on, additional collateral that'll be some of it enterprise targeted. We have MNO targeted material. We do deployment guides for 5G, neutral host. So be on the lookout for those, and definitely join the Alliance if you want to be a part of putting those together. We also have our OnGo Forward event this year is going to be at actually Network X, co-located with the WBA. That's on May 19th, 20th in Dallas. And we'll have both a public session and an internal members meeting. We'll also have our own OnGo pavilion there. So let me move to questions. And Richard, while I'll stay on this slide for the questions, the first one is for you. It's from Warren about are the WISPs mostly supporting the 100 down, 20 up federal definition of broadband? And he's interested in the density aspect for upload. Not to get too technical there, though. Yeah.
Yes, most WISPs. Well, certainly the national standard at this point is 100 by 20. Though many WISPs provide a much higher offering than that, up to and including fiber level deployments. I think if you do a national examination of residential uses, not just in rural areas, but across the entire United States, you will find that those parameters, the 100 by 20, pretty much service most of the needs of people throughout the country, though WISPs usually offer a range of offerings, including higher speed and higher offerings up to gigabit, and where necessary, even symmetric offerings. That is an interesting question because originally the FCC and the NTIA were looking at symmetric gigabyte requirements. If you really look into what's used in the United States, that is very, very rarely used, especially on the uplink portion. And so the sort of staggered use of spectrum offerings like 100 by 20 or even going up from there, typically you wouldn't offer as much on the uplink side because it's just it can be a waste of spectrum. I'm not sure I answered your entire question, but that's what I heard. Masoud,
Yeah,
did you have
definitely
anything to add?
works. No, and just continuing that, again, for you, probably, Richard, in rural areas, what competition are you, as in, I guess, WISP, seeing from Starlink and possibly Amazon Leo, I guess, in the future?
Yeah, I think that there's certainly a new entrant into the offerings for covering the United States and beyond. And we do see some competition with respect to LEO offerings, but LEOs have not yet gotten to the point where they can cover all of the traffic associated with rural areas. And you do have to understand that just like in any kind of fixed wireless operation, there is a certain amount of line of sight requirements that are necessary both for fixed wireless operation and for satellite. In places like the Appalachian, places where there are a lot of trees, it's not always that easy to get signal in from satellite. So I would say that having both of those available is beneficial to the country because you have opportunity to fill all of the areas that are not covered, but certainly it adds a layer of competition.
Yeah, can I add one, Richard? Oren, can I add just a view?
Sure.
Yeah, actually, I really don't want to call it competition, as Richard mentioned, and you can see that as part of this speed program that is a heavy and large kind of tool to enhance the use of wireless in rural areas. So I would call them complement of each other because the need and the need for higher capacity, higher coverage in rural area is really great. In the United States is a big country, and there is a lot of need for wireless spectrum and wireless deployment. So I wouldn't call it competition. I would call it complement, and both CBRS and satellite system together can provide services in rural areas.
Also, I'll add one more thing to that because I agree with what Masoud said. One of the best things we can do for American population is have choice. And where there is more than one option, it benefits things. It allows for competition and in the general industry sense, and it allows for opportunities for everyone to have good service. So we welcome that.
Okay, here's one definitely for you, Masoud. And Patrick asks about what's the most popular design topology regarding CBRS in the context of passive DAS and active DAS?
So first of all, I invite you to look at some. I mean, if you are a member of OnGo Alliance, look at the ongoing work on that. We are developing a white paper. There is a task group, and also the same activity is going on in Wireless Innovation Forum. We are looking at different methodologies, but just to summarize it, so the topology that we are using, if you are talking about the configuration of the network, so we are looking at three different modes of operation and three different configurations. One is if you use purely passive DAS, in which case we have some active radio, we have a RAN, and then all of the elements after the RAN are passive elements, cables, splitters, and antennas, and passive antennas. So that's one mode of operation that we have seen already deployments in CBRS, and SASs are supporting that. The second mode of operation that we are looking is that if you are assuming that all of the antennas that are being used in a DAS system, the distributed antenna system, they already have some integrated active element. And in that case, basically we call that fully active, and that is supported. We have developed the requirement, SAS requirement, as well as the CPI plan to address that. And also we have worked with FCC to come up with the certification plan. And the third configuration, which is actually the most used and the most common use, is a combination of these, which means that you can have topologies where like a RAN operator like Ericsson, Samsung, Nokia, others, they feed a central active DAS controller, and then the central active DAS controller manages either fully active antennas, I mean antennas that they have active elements integrated into them with power amplifiers, or some active elements that already that basically feed a passive network. In other words, you can have a hybrid of these, and all of these topologies are supported by CBRS. Once again, if you want to look at the detail and you are a member of OnGo Alliance, please look at the work that the DAS task group is working together.
I think we have time for one more, which I'll actually take it, and Masoud and Richard, feel free to take it from there. But are there any untapped verticals where CBRS based private networks have strong potential but limited deployment? And I'll just say two verticals that come to mind. One is definitely smart agriculture. We're starting to see the potential there is huge. There's hundreds of thousands of farms in the US who have coverage issues. And I've seen solutions where a vendor just drives up there with a cell on wheels, and within an hour, he's already getting connectivity and starting to think, especially when they're getting more and more sophisticated with smart agriculture, they need connectivity and they don't have it there. And it's kind of the perfect definition of a private network. So that would be one. And the second would be, I think, healthcare, which we're starting now to see. Again, they're a little slow to adapt, but they're still working with Ethernet cables, carts, and faxes and beepers there. And they definitely have a huge need for something like this. And I'm willing to bet that, again, those would be two verticals that will expand immensely in the near future. I don't know, Masoud.
Thank you, Oren. I think you captured two of the ones that I wanted to mention. I want to add two more that we have deployment in the country, but they have a lot of room to grow. One of them is education. I think CBRS has a lot of potential to enhance the education systems in the campuses as a complement to like the current operator MNOs. So campuses need a lot of capacity, and the CBRS has a lot of potential to enhance that network. The second one that I want to mention is the transportation and aviation industry that we have recently seen. For example, as you said, Miami Airport has started, so there are a lot of room, and for both of them, solutions like neutral host network can be used. DAS and active DAS, even combined active DAS and neutral host network can be used to enhance the capacity and coverage on those fields.
I agree with all of those and expand to areas that utilize sensors, such as IIoT applications. That would include precision agriculture and dairy, but also things that like hospitals where telemetry is used. There are a lot of indoor uses that could be expanded as well, and certainly a lot of opportunities for vertical market penetration.
Oren, sorry, there is one item. I know that we are toward the end, just in 30 seconds. Unfortunately, we did not cover in this webinar, and because it was not the material of this. So I'm talking on behalf of like a SAS administrator. I'm working in Federated Wireless. We are working heavily to make sure that all of the advances and improvement that can be brought up by AI can be exploited in CBRS. CBRS is a perfect technology that can heavily use AI advances. because it's mainly software based. It relies on the models, and those models can be heavily efficient and updated and improved by using measurement, by using data and AI tools and AI techniques. Um, Federated, we have even using a lot of kind of tools that are using. I'm sure other SaaS admins are looking at that. So CBRS opens the door for employing all of the AI advances in improving the models that we can use. It only requires the regulatory team to work with us and make sure that we are allowed to use those methods to enhance the availability of spectrum in CBRS. Over.
Okay. We're at time, and I'll try to get back to the questions offline for some of the people here. And thank you very much to the speakers and for those attendees. And we're done. Thank you very much.